Hey everyone, this is Derek Wolfson. I'm the GSI who teaches on Mondays, and I am going to record a lecture on corrective policy with pre-existing distortions, which is the Buchanan model, and uncertainty, which is Weitzman. I know a number of you didn't get to see this lecture given the craziness around the coronavirus, so I'm doing this as a little bit of a pilot to see how well this stuff is going to look as we post it to YouTube so you guys can have a virtual lecture. So let's dive right into Buchanan. The Buchanan critique, which is also noted in your lecture slides as the monopoly model, or at least under the monopoly heading, states that if there are pre-existing distortions in the market, like monopoly power, the Pigouvian prescription can actually lower welfare. So I think the easiest way to do this is to look at this graph. So if you recall, monopolist price, where marginal revenue equals marginal cost, okay? The social optimum is where marginal benefit, or the demand function, crosses marginal cost. So again, if this is where the monopolist produces at QM, they're going to charge a price of PM. Remember, prices are determined by the demand curve in this market. The social optimum is determined by this intersection at Q1S, at P1S. Then the monopolist is producing too little at too high of a price. And the deadweight loss that the monopolist induces in this market is equal to this pink triangle. So these are all the units that we would like to consume, but the monopolist does not want to produce those because their profit maximizing quantity is where marginal revenue equals marginal cost. If you need a reminder as to why the monopolist prices at that point, look at section notes number 1. There's a mathematical and graphical interpretation of that, and I think that should be good, but you should just kind of stamp that into your head that that's where the monopolist price is. Okay, so, there's no externality in this market. The deadweight loss is not coming from an externality, it's coming from the market power that the monopolist exercises on this market in order to maximize their own surplus or their own profits. So what would happen if instead there was a externality? So I'm going to build a little bit of a contrived example to show you that if there is a negative consumption externality in this market, that it is possible for the monopolist choice of quantity to actually correspond to the socially optimal quantity. So let's assume that the marginal externality shifts the social marginal benefit curve inward as such. So we're going from this curve to this curve. So now let's start thinking about various quantities in this market. So the social optimum now is at the intersection of this curve and marginal cost, which we find is right here. But we also know that this is exactly where the monopolist wants to produce, because their marginal revenue curve intersects their marginal cost curve at this exact same point. So what this tells us is that when we have this negative externality and marginal social benefit is lower than marginal benefit, it's possible that the monopolist, by reducing their privately optimal quantity, is actually solving this externality problem for us. Now, they're doing it unintentionally because they're doing what they're doing based on private incentives to profit maximize. They are not incorporating this externality. But it does lead us to have work to production at QM, which is the intersection of the marginal social benefit curve and the marginal cost curve. So it's possible that the monopolist can just solve this problem. Okay, that's what I want you to take away from this graph. But what would happen if instead the planner didn't know that the monopolist was already solving the market failure, or the market failure associated with the externality, and applied a Pigouvian tax to this market? In this case, the monopolist marginal revenue function will become MR2, and they will actually produce way too little. So let me go to the whiteboard to go through this example. So here we have that same market: marginal benefit, marginal revenue, marginal cost. This is all the monopolist market. Let's draw in the social marginal benefit function that we drew in previously. I'm going to draw that in red. Should look a little something like that. Let's call this social marginal benefit. And we know that the Pigouvian prescription is looking at the intersection of marginal benefit and marginal cost and measuring the difference between that and the social marginal benefit at that quantity. So this would be the tax that we'd want to put on this market to restore efficiency if this were not a monopolist running this market. So what that really means is that we can change this social marginal benefit function to be marginal benefit minus tax. And if the monopolist is then looking at this curve as what they want to price on, then what they're going to do is say, okay, well, this is my relevant demand function. I'm going to build my marginal revenue function off of that demand function. So let's call this MR2. And I'm going to produce where MR2 intersects marginal cost to maximize my profits. So the monopolist is going to produce at that red dot at some price way up here. Let's call this PMT. Let's call this QMT to denote the monopolist equilibrium under the tax. And recall previously they were going to produce where marginal revenue intersects marginal cost, which is right here. So this is QM. And what I want you to take away from this graph is that QM, which is also the social equilibrium in this case, it's the welfare maximizing quantity since social marginal benefit intersects marginal cost at that point, is greater than what the monopolist will produce if we put the naive Pigouvian tax on them, which is given by this vertical distance. Okay? So what I want you to take away from that is that if the social planner does not incorporate the monopolist's behavior and how the monopolist is going to price and how they're going to choose output in this market, then what's going to happen is we're going to actually over adjust below the social equilibrium. We're going to go to QMT instead of QM and induce this pink triangle of deadweight loss. And that's exactly Buchanan's critique, is that if there's a pre-existing distortion, a la monopoly in this example, then applying the Pigouvian prescription can actually lower welfare. Okay? So let's go to the takeaways. First one is the Pigouvian prescription does not work in the presence of other distortions. We covered that. It is possible that the monopolist produces either too much or too little of the good, generating a negative externality. We're going to explore this in the exercises. If a monopolist produces too much of a good, then the optimal policy is a tax. A tax will restrict output. If the monopolist produces too little, an optimal policy will be to subsidize the monopolist so that they produce more. In the case of positive externalities, we are already consuming too little of the good, so the additional supply restriction of the monopolist implies that we'll need even larger subsidies to restore efficiency, which we'll get into in one of the exercises down below. And to restore efficiency, we need marginal revenue and private marginal cost to intersect at the socially optimal quantity.
Okay, so now that we've covered all the takeaways, let's move into the exercises, which I'll try to do on my iPad here. So this first exercise is a true-false question from a midterm in 2017, and it says a monopolist produces a good called shmoo, which has a positive externality, and true or false, the optimal subsidy for shmoo could be larger than or smaller than the marginal external benefits at the optimal quantity. So the way I'd go about answering this question is probably graphically. So let's put our axes down, quantity and price. Let's just throw a marginal cost curve in here that's flat. So we'll just assume this monopolist has flat marginal costs. Let's throw a demand curve in here, or a marginal benefit curve. Let's do that. So remember, we have a positive externality, so the social marginal benefit curve is going to be shifted out. There's our social marginal benefit. And then if this is our marginal benefit curve, then let's draw the marginal revenue curve, since we have a monopolist and that's how they're going to price. So let's just not mark off all the quantities here. So this is the social optimum at the intersection of social marginal benefit and marginal cost. So let's call this QS. This is the kind of private optimum if we don't internalize that externality at the intersection of marginal benefit and marginal cost. Let's call that QP. And this is where the monopolist would want to produce at the intersection of marginal revenue and marginal cost. So what we see is that QM is less than QP is less than QS. So we know that the Pigouvian prescription will move us from the private equilibrium up to the social equilibrium. So this will be Pigou. But to get all the way from down here at the monopolist equilibrium all the way up to the social equilibrium, we're going to need a much larger subsidy. And really you can just intuit that because we need a larger supply response to go from this value to that value. So the answer to this question is false, and it's because the optimal subsidy for Shmoo is larger, will always be larger. It'll never be smaller than the Pigouvian prescription, which is explained by the marginal external benefits at the optimal quantity. Okay, good. So now let's move on to the algebra question of this section. So now we're considering the economy for gallons of paint. Marginal private benefits are given by this function, 100 minus 2q, and marginal private cost is given by this function, 10 plus q. Supply is subject to a negative externality since the creation of paint creates pollution, and paint is supplied by a monopolist who does not consider the marginal external damage from their production. So let's start with A. We want to graph the monopolist marginal benefit, marginal revenue, and marginal private cost functions, and then determine the price and quantities where the monopolist produces. All right, so let's come down here and do that. So we're given the marginal benefit function. It's 100 minus 2q. So to get the total revenue function, we multiply q times the marginal benefit of q. Remind yourself that this is equivalent to doing q times p, so that would be their total revenue. If you need a reminder of that, look at section notes number 1. So that is simply q times 100 minus 2q, which is 100q minus 2q squared. All right, cool. So now that we have total revenue, now we know that marginal revenue is the derivative of the total revenue function, total revenue prime. So this is equal to 100 minus 4q, and we're given the marginal cost function as 10 plus q. So given all that information, we can start graphing this and then finding the monopolist preferred level of output and price. All right. So let's start with marginal benefit. It starts at, say, 100, goes down with a slope of 2. So it comes down to, say, 50. Let me redraw that. Say that's 50. The marginal revenue function starts at 100 and comes down and hits at 25. And the marginal cost function starts at 10 and goes up with a slope of 1. So something like that. All right, good. So let's label these. This is marginal benefit. This is marginal revenue. So we know the monopolist is going to want to produce at this black dot. So let's determine what that value is mathematically, and then we can label things. So the quantity is going to be determined by where marginal revenue equals marginal cost. So we know those two functions, so let's just set them equal. So marginal revenue, Q, is equal to marginal cost, Q, is equivalent to writing down 100 minus 4Q. Sorry, Q is equal to 10 plus Q, which is 5Q is equal to 90, which is Q is equal to 18. All right, good. Let me put this in red. All right, so we have 18 right there. To get the price, we take this value of 18 and plug it into the demand function, because really what we're doing is thinking, okay, we're setting quantity here. We get the price off of the demand curve, and then we need to know what that vertical value is. All right, so we have 18. We plug that into our marginal benefit function. So price is going to be equal to marginal benefit at 18. So price is going to be equal to 100 minus 2 times 18, which is equal to $64. All right, so now we have our quantity. Let me actually do that in red too, just to keep everything consistent. $64. So the monopolist would like to produce 18 units and sell them for $64 each to maximize their profits. All right, so now let's come up and look at B. So now it says if we ignore the pollution externality, what is the socially efficient level of paint production and at what price does this occur? So what we can do, let's actually just bring this down and do it on a fresh sheet. All right. So for B, we want socially efficient. This is at this intersection where marginal benefit intersects marginal cost, so we can do that. So this is marginal benefit Q is equal to marginal cost at Q. We know the marginal benefit function is 100 minus 2Q. We know the marginal cost function is 10 plus Q. So this gives us 3Q is equal to 90 and Q is equal to 30. So let's mark this off in gray. Now to get the price, we can plug this value of 30 back into our marginal benefit function again. So price is equal to marginal benefit at 30, which is equal to 100 minus 2 times 30, which is equal to $40. All right, let's mark that off in gray. See if I can... Great. All right. So now we see that our socially optimal level of production is 30. It is greater than how much the monopolist wants to produce, which is good since the monopolist usually wants or always wants to restrict output to maximize their profits. Okay. So now for C, what we're asked to do is determine the marginal social cost function if the marginal external damage is 15 per unit. And then we want to determine the efficient level of paint production when we include the externality. So let's do that down here. So for C, marginal external damage is equal to 15. And then we can say the social marginal cost under the $15 externality is equal to the marginal external damage plus the private marginal cost function. So SMC 15Q is equal to 15. This is the external damage plus 10 plus Q, which equals to 25 plus Q. All right, so now let's draw this on our graph. Let's bring this down once again. All right, so I'll do this in pink. So our marginal cost function is going to, or SMC, is going to have the same slope as this function, but it's going to be shifted upward by 15 units. So it should start right about here. And look a little bit like that. All right. So the social optimum is going to be under SMC 15, where this curve intersects the marginal benefit curve, which is that pink dot I just indicated. So let's determine what that value is. So that's going to be setting SMC 15Q equal to the marginal benefit Q. So this is going to be 25 plus Q is equal to 100 minus 2Q. This is 3Q is equal to 75, or Q is equal to 25. So let's mark that off on our graph. So it's going to be right at that level 25 where our marginal revenue function hits the origin. And to get the price at that point, although I don't think we even need the price in this question. Yeah, we just need to know the efficient level of production. So let's come back up to D. So now we want to compare this level of production we just determined from part C to the monopolist's preferred level of production from part A. And then what tax or subsidy will ensure the monopolist will produce at the socially optimal level, and how does this compare to the naive tax, Pigouvian tax or subsidy? All right, so let's first think about D. So Q monopolist is equal to 18, and then Q15, which I'm calling under for the marginal cost or external marginal damages of $15, is equal to 25 units. So QM is less than the social optimum Q15. So what we need to do in this case is subsidize the monopolists so that they produce more. Okay? So let's determine what that subsidy is. So if we look at this graph, what we want to do is essentially have this marginal revenue curve, this one right here. We need to move that so that it intersects this marginal cost curve. Sorry, let me trace that once again. This marginal cost curve at the level of 25. So let's grab this, copy, paste. I'm going to turn it pink so that it's clear what we're doing. Sorry. Let's make it a little bit thicker, right about there. Good. So this is now their marginal cost curve. Let me just overlay it so you believe that that's the exact same curve. Now what we want to do is start moving it around and thinking about where do we have to move this to get that this intersection of this thick pink curve and the marginal cost curve way out here intersects at 25. So I'm going to drop it right about there. And if we zoom in on that, now we see that the intersection is at this point in black, which is exactly at 25 units if we trace this down. So if we call this pink curve, say MR2, well, let me zoom out so we can write some notes about this. Well, we know MR2 is going to be equal to MR1 plus some subsidy. So let's determine what this value is, because we shifted this curve outward, which means we're giving the monopolist a little bit more revenue each time they sell something. So if we want to measure this, what we need to think about is, okay, well, how much do we move this marginal revenue curve? Well, we moved it from starting here at 25 to being all the way up here at 25. So it's going to be this vertical distance I'm indicating with this black shading. So we can do that mathematically by looking at setting the subsidy equal to the marginal cost function at 25. That's this point right here. And subtracting off the marginal revenue function at the quantity of 25, which is this point down here, which is 0 in this case. So the subsidy is equal to the marginal cost at 25 minus the marginal revenue at 25, which is equal to 10 plus 25 minus 0, which is equal to 30. Sorry, yes, no, that's correct, which is $35. So the subsidy is given by this vertical distance, which is $35 subsidy. And that will move this marginal revenue curve right here to intersect this marginal cost curve at the quantity that we want, which is 25 units. So if this is the subsidy that the monopolist, we need to give the monopolist in order to restore efficiency in this market, let's think about what the Pigouvian tax is. Well, our marginal external damages are $15. They're fixed, so the tax Pigou in this case is a $15 tax. So in this case, the Pigouvian prescription is a $15 tax, and the actual policy we want to do is a $35 subsidy. So in this case, not only does the instrument change, so we go from using a tax to a subsidy, but the value changes quite a bit, and there's actually a $50 difference between the $35 subsidy and the $15 tax. All right, let me add a page because we're going to need a little more space to do the next part of this question. So in part E, we're going to do exactly what we did in C and D, except for our marginal external damage is going to be $54 per unit. All right, let me grab this right here. We're going to need another graph, no need to redraw it. All right, for E, we're given that the marginal external damage is $54. So our social marginal cost at 54 is equal to $54 plus 10 plus Q, which is equal to 64 plus Q. Let's again draw this function in pink over here. It's going to have the same slope as this marginal cost curve, but start at 64. So it's going to look a little something like that. Social marginal cost 54. The monopolist will produce where this social marginal cost curve intersects the marginal revenue curve, and the new social optimum is going to be where the social marginal cost curve intersects the marginal benefit curve. Okay, so let's first determine the social optimum in this case. Or sorry, that first dot was wrong. All we need to do is determine the social equilibrium since we haven't actually moved any curves for the monopolist yet. So just to recreate or recover that, all we need to do here is check for the intersection of this curve and the marginal benefit curve. Okay. So if we set SMC 54 equal to the marginal benefit function, we are given 64 plus Q is equal to 100 minus 2Q, which gives us that 3Q is equal to 36 and Q is equal to 12. So let's mark that off in pink. So that's 12. And we see that remember that the monopolist is still going to make their production decision at the intersection of marginal cost, or the private marginal cost, and the marginal revenue function. So the monopolist still wants to create 18 units, but what we've discovered is that the social equilibrium in this case is 12 units. So in this case we have QM is equal to 18, Q social is equal to 12, and we're going to need a tax to lower this QM to equal 12 units. All right. So we've done E, we've done this little bit of F where we compare the level of production from part F to the preferred level of production from part A, or the monopolist. And now let's think about what tax or subsidy will ensure the monopolist will produce at the socially optimal level, and compare this to the naive Pigouvian tax or subsidy. So let's first start with the Pigouvian tax. So we know our marginal externality is $54. So our Pigouvian tax is going to be 54. And let's start thinking about what the right tax is for the monopolist. So again, let's think about moving their marginal revenue function around so that it intersects marginal cost, or this private marginal cost function, at the social optimum of 12 units. So let me style this as pink and a little bit thicker just to keep things clear. So we're going to slide this around. Here it's overlaid the original marginal revenue function, but what we want it to do is intersect at this pink level, which is right about there. So let me call this marginal revenue 2. And we know that marginal revenue 2 is equal to marginal revenue 1 minus some tax. And what's the level of that tax? Well, what we want to do is measure the difference between marginal cost and the marginal revenue function at the optimal level of 12 units. So it's going to be this vertical distance right here. So we can do this mathematically. So we can say the tax is equal to the marginal revenue at 12 minus the marginal cost at 12. So that is this point minus this point. So let's just determine what those values are. That is equal to 100 minus 4 times 12 minus 10 plus 12. So we have equals 100 minus 48 minus 22, which is equal to 100 minus 70, which is equal to 30. So what we've shown is that this vertical distance is $30. It's a tax, and that we know that the new, or that this is the tax that will restore the monopolist to produce right here, which is what we want them to do, so that they'll produce these 12 units. How does that compare to the Pigouvian prescription? Well, the tax we need for the monopolist is 30, the tax we'd need without a monopolist is 54, and that should make some sense since the monopolist is already taking into account kind of some of the negative externality by reducing output to increase their profits. So they're not really internalizing the externality, but just by their private behavior, they're kind of helping us get there by reducing output. So what I want you to take away from this problem is that things get a little more complicated. You can't just use the Pigouvian prescription when you have other market failures, such as monopolists in the market. And in some cases, like in this case, we actually change basically the type of policy we're using. A subsidy is how we restore efficiency in this market to get the monopolist to act in accordance to the social optimum. Whereas if we naively did this, we'd charge a tax and actually knock the market even further out of equilibrium and create even more deadweight loss. So in this case, we have a smaller tax than we'd want under the Pigouvian prescription, but it just goes to show you need to model these things very carefully, and we hope that this problem will help you get there. All right, cool. So let's move on to Weitzman. I think I can do most of this just on my iPad. So yeah, Weitzman is more about uncertainty. So this is about choosing the correct policy instrument once we are kind of building in realism into our model. We recognize that we're not going to know either the marginal benefits of abatement perfectly, and we're not going to know the marginal cost of abatement perfectly either. There's going to be uncertainty in these values. You saw this in Max Offhammer's lecture if you attended that, about how much work just goes into understanding the social cost of carbon. And we have some idea of what that number is, but it's really just kind of a mean of a very large distribution of numbers that we've estimated. So we don't know the true value, but we do have some best guess. And Weitzman is about what we should do, what type of policies we should choose if we're going to be kind of making guesses based on our expectations. So we know from our discussion of externalities that if we pick the wrong level of abatement or of any policy, we will not achieve efficiency, and we will have some deadweight loss in that market. And as I said before, with uncertainty, we don't know the optimal Pigouvian tax with certainty. So a prudent question to ask is whether a price or quantity policy may lead to smaller mistakes, i.e. less deadweight loss. So I think it's really useful to draw these graphs on your own. I'm going to go through them on these notes and try to get you there, but I think the way you really grok this model is by drawing this stuff on your own and really just starting to understand the mechanics. So let's dive into the main takeaways. If there's uncertainty about benefits, then price and quantity instruments produce the same outcomes. All right. So let's go through that in this graph. Let me zoom in on this. So let's start. If we choose a quantity instrument, then we're just setting our quantity right here, which is at the intersection of expected marginal benefits and true marginal cost. There's no uncertainty in marginal costs here. And if we set a price instrument at this same intersection, well, we get right here. Recall that abatement decisions are going to be done where marginal cost is equal to price. So if we set the price right here, then we're going to get abatement at this level. So whether we set the price or the quantity instrument, we're going to basically target this level, Q prime. So what that means is that if this is our expected value right here, this expected marginal benefit function, well, no matter whether we use the price instrument or the quantity instrument, we're going to kind of get this much abatement in the market. So if this is our true marginal benefit function, then we really want to be abating up here at a higher price and a higher quantity. And this is all deadweight loss, is this pink area. So this is our losses. But since both the price instrument and the quantity instrument led to this this value of abatement, it doesn't really matter whether kind of this uncertainty where expected marginal benefit became true marginal benefit, because the deadweight loss is the same. So we still don't want to get it wrong, but in this case it doesn't matter whether we use a price or a quantity instrument. So yeah, let's go into the next little bit, which is uncertainty about cost, where it does matter which instrument we want to choose. So if we are uncertain about costs, then price and quantity instruments create different outcomes. So if the marginal cost curve is relatively steep in relation to the marginal benefit curve, then a price tax instrument will induce less deadweight loss under uncertainty. Okay, so let's walk through this. Let's start over here with the quantity regulation. So again, we have a marginal cost 1, which is our high marginal cost situation. We have marginal cost 2, which is our low marginal cost situation. And then what we're saying is that we have some expectation, which is just the combination of these two. So you can think of it as we're going to get marginal cost 1 or marginal cost 2 with a coin flip. So it's just equal probability on both sides. So if we set our policy, let's start with setting the quantity regulation here. If we set our policy based on the expectation, then we're going to look at the intersection of marginal benefit and the expected marginal cost curve, which is going to be set right here. So a quantity policy is going to set us to be at this level basically no matter what, no matter if we have MC2 or MC1 as our realization. So what does this do? Well, let's look at what happens if we observe MC2 in reality. Well, if we have MC2 in reality, what we want to do is be right here. This is the intersection of marginal benefit and our true marginal cost. And we want to be abating here, but we're forced to be abating here because we set our policy there. So all this gray shaded area is deadweight loss, okay? Because these are additional units that we'd like to abate, but we didn't set the policy properly to achieve that level of abatement. Similarly, if we have high marginal cost, we go to marginal cost 1. We want to abate less at a higher price than we are under our expectations. So, but instead we're going to be at this level right out here. So all of this is going to be deadweight loss because we abate here, or we would like to abate here. That's the socially optimal level, but we're going to be abating out here because that's where we set the policy. So let's come over to a price instrument. Notice that these curves are exactly the same: marginal cost, expected marginal cost 1, and marginal benefit. We're just changing which policy we're going to start with. So let's start with a tax policy here. So we're going to set this policy based on the intersection of expected marginal cost and marginal benefit. So these two curves, this is going to be our tax right here. And what happens if instead we observe the low realization of cost, so MC2? Well, our efficient level of abatement is still right here. But what happens in this case? Well, remember, firms are going to abate up to our marginal cost equals price. So that's going to be at this point, because that's where price is going to equal marginal cost 2. And we are going to abate up till here. So the difference is that we're going to abate all these additional units. We're going to abate too much because the price is set too high. And it's this triangle here that becomes deadweight loss. In the other case, if we observe marginal cost 1, the price is still here. Remember, we're still going to abate up to where marginal cost equals price. So we're going to abate right here. And we really want to be here. This is the social optimum where marginal cost 1 intersects marginal benefits. So it's going to be that this triangle is deadweight loss because we're going to achieve this level of abatement when we really want to be here. Okay? So what you should take away from this is that these triangles over here are much bigger than these triangles over here. So this is why we say the price instrument will induce less deadweight loss under uncertainty. So what you're doing is comparing these graphs across and thinking, okay, this area looks much smaller than this area. So in this case, the price instrument wins when marginal cost curve is relatively steep in relation to the marginal benefit curve. So let's do it the other way around. What if the marginal cost curve is relatively flat in relation to the marginal benefit curve? Well, in this case, then a quantity instrument will induce less deadweight loss under uncertainty. So let's walk through this. Let's again start on this side where we're setting the quantity instrument. Again, we have a low realization of marginal cost, we have a high realization of marginal cost, and our expectation is a coin flip between the two. Our marginal benefit curve here is much steeper than those marginal cost functions. So if we set the quantity instrument, again, we're kind of restricting ourselves to be along this vertical line. And what happens if we have high marginal cost in this market? Well, again, we want to be here, but we're really going to get abatement right here. So this becomes the deadweight loss from that policy. Similarly, if we have high realizations of marginal cost with marginal cost 1, we want to be abating here at the intersection of marginal benefit and marginal cost. But we're really going to abate here because we fixed the quantity basically by the policy, and this is going to be our deadweight loss. So again, if this is confusing to you, I'd recommend drawing these curves on a blank sheet of paper and just trying to figure out where the deadweight loss is in these diagrams. Now, if we use the price instrument, we're going to set our policy here. We're setting a price policy, so let's set it on the y-axis. This is going to be our tax, or our price, however you want to think about it. Recall that marginal cost equals price is where firms are going to abate up to. So let's look at what happens under the realization of low marginal costs. So if the tax is here, we're going to get abatement all the way out here. We really want to be here. This is the intersection of marginal cost 2 and the marginal benefit of abatement. So all of this gray area is deadweight loss. And similarly, if we look at marginal cost 1, again, firms are going to abate where marginal cost equals price. That's going to be way back here, close to the origin, or at least close to the origin on the x-axis. We really want to be up here, abating right here. But the policy is going to induce this much, so the deadweight loss is going to be this large triangle right here. All right. And then what you should be taking away is that these triangles are larger than these triangles, so we'd want to use a quantity regulation here to minimize the expected deadweight loss under uncertainty. All right, cool. So that's when the marginal cost curve is relatively flat in relation to the marginal benefit curve, then a quantity instrument will induce less deadweight loss. All right. So just a quick note, most economists think costs are steeper than benefits for carbon and thus prefer a carbon tax to cap and trade. So with that, let's dive into the exercise portion of Weitzman. So you are an economic advisor to Skyresh. He is thinking about implementing a carbon tax or cap and trade system to reduce carbon emissions. They are currently researching the benefits and costs of abatement, and the latest estimate of the marginal benefits of abatement are marginal benefits hat, which is equal to 30 minus 2q, and they currently expect the abatement technology to be marginal cost hat, which is 6 plus q.
So let's dive right into this. Part A is asking you what is the expected optimal level of abatement and associated estimated optimal tax. So we're going to determine that by setting marginal benefit Q equal to marginal cost Q. So you're going to get 30 minus 2Q is equal to 6 plus Q. This is 3Q is equal to 24, and Q is equal to 8. To get the optimal tax, we can plug in this value of 8 into our marginal cost function. So marginal cost hat at 8 is equal to 6 plus 8 is equal to 14. All right, so that kills it down to A. So new research shows that the marginal benefits may be different than expected. Skyrish asks you if he should use a price or a quantity instrument now. What do you suggest? Commits him with a graph. Okay, cool. So uncertainty on marginal benefits implies P or Q are the same. If you remember this from the lecture portion just a few minutes ago. But let's use a graph to convince Skyrish of this. So I think I should have some of this graph stored here. Good. Erase some other stuff. Okay, cool. So this is our expected marginal benefit function. This is our expected marginal cost function. And what we want to do is induce some uncertainty into marginal benefits. So let's just draw a different marginal benefit function, say out here. Let's call this marginal benefit 1. And let's think about what happens under a price or a quantity instrument. So I'll do all the price stuff in red. Actually, let me make sure that that is right. Yeah, I don't want to, later in this problem I use blue and red. I just want to make sure I'm being consistent. So the price policy is going to be set at the intersection of marginal cost, expected marginal cost, and expected marginal benefit, which is right here. We determined what this value was previously. This is going to be 14. And remember that firms are going to abate where price equals marginal cost hat in this world. So they're going to choose this level of abatement. Really, they want to be at this level of abatement. So the deadweight loss is going to be this area between these two curves. This is where we're abating. This is where we should be abating to maximize social welfare. So this is the deadweight loss in that red area. So now let's do the quantity instrument in blue. Before we showed that the quantity required is at 8 units. So we're saying the quantity directly at 8. We're kind of restricting ourselves to this level of abatement based on the policy. Remember, this is coming from this math up here. We still want to be abating right here. This is the intersection of the true or realized marginal benefit and the true or at least expected marginal cost in this world. So our deadweight loss is this area. So the blue hashed area and the red hashed area are equal to each other, so price or quantity is equivalent. All right, cool. So that's part B. So now part C, the latest discovery is that marginal benefits actually look like this. Marginal benefits tilde 45 minus 2Q. Now we want to calculate the deadweight loss associated with the tax calculated in part A. And what about for the equivalent quantity regulation? Okay. So let's come down here to do part C. I believe I should have a extra graph floating around. Cool. Let's bring this up here. All right, so we're starting off here. We have our expectation. We have our expectation of benefits. This is expectation of costs. And what we need to graph now is marginal benefits tilde, which is some realization, which is 45 minus 2Q. So it should look something like this. Actually, let's just draw it like so. Should be right about there. All right. So as before, we know that if we set a policy and we have uncertainty in marginal benefits, well, the deadweight loss is going to be determined under either price or quantity at this level. So let's determine what we need to know to actually estimate or calculate what that area is. So we know that this point is 8, 14. This is the intersection that we determined in part A. So now let's determine this point here. This point is going to be determined by the intersection of marginal benefit tilde and marginal cost hat. So this is going to be 45 minus 2q equals 6 plus q, which gives us 3q is equal to 39 and q is equal to 13. So we know that this value here is 13, and then we need to know this vertical value here to determine this. To get that, we need to plug the value of 8 into this marginal benefit tilde. So marginal benefit tilde at 8 is equal to 45 minus 2 times 8, which equals 45 minus 16, which equals 29. Okay, so then to get the area of this triangle, we just need to do width times height divided by 2. So deadweight loss is equal to 29 minus 14 times 13 minus 8 divided by 2, which is $37.5. Okay, cool. So we got that done. So as before, the deadweight loss should be the same for a tax and equivalent quantity regulation. If that's not absolutely clear to you, you should have seen that in Part B, but in Part C, we just know that this is the deadweight loss under both policies. So now let's move to Part D. So Part D says research indicates that abatement will be more costly than expected. The most recent estimate takes the form MC equals 12 plus Q, but it could change again. Now Skyrush wants to know if he should choose a price or quantity instrument in the face of this uncertainty. Okay, convince him again with a graph. Okay, so let's grab this graph again. This is kind of our base graph here. And what we need to add to this graph is this marginal cost function, which equals 12 plus Q. So let me remind you, marginal benefits in this case are equal to 30 minus 2Q, and then marginal cost hat is equal to 6 plus Q. So one thing you could do is look at these values and say, well, it sure looks like the marginal benefits are steeper than marginal costs. And in this case, if you recall the lecture, when marginal benefits are steeper than marginal cost, this implies use quantity instrument. Okay. So given that, let's actually graph these things and try to determine how this all works. So our new marginal cost function is going to start at, say, 12. It's going to look a little something like this. So this is marginal cost associated with this function, 12 plus Q. So let's start marking off what happens under a quantity and price policy. So let me start with the quantity policy in blue again. So the quantity policy, again, we're setting our policy based on our expectations, which are given by these hat functions. So the quantity is, again, at 8. If we know that this is now the marginal cost function, we want to be abating here at the intersection of our realization of marginal costs and our expected marginal benefits. So our deadweight loss is going to be given by this area. Okay, so this is under quantity. That's the deadweight loss from this change in marginal costs. Marginal costs get more expensive. All right, so in red, let's do a price instrument. So the price instrument is done right here at 14. We're getting that value from our answer to part A. Remember, firms will abate up to where price equals marginal cost, which is this curve. So they're going to abate this quantity. We really want them to be abating this quantity because that's the expected marginal benefits and the marginal cost curve. However, we set the price too low, so we're only going to get this much abatement, and the deadweight loss is going to be this large red area. So this is the price instrument. So as we kind of intuited, marginal benefits are steeper than marginal costs, so we want to use the quantity instrument. And you can see that because, well, this blue area is much, much smaller than this red area. Okay, so that's what you want to do with Weitzman. This is the sort of stuff you'll be doing on your problem set, or probably have already done on your problem set. And yeah, so that concludes this lecture. Let me just make sure I'm not missing anything out of this question. Yeah, so that's Weitzman. As before, thank you everyone for your flexibility during this time. This is pretty unprecedented for us. We've we're trying to do our best to keep the learning objectives in mind and keep the level of instruction high. So any feedback you have, please do let us know, and we'll work on making these videos better and better as we go along. So yeah, thanks for tuning in. We look forward to interacting with you remotely.